welcome to this special Autovista Group video. I'm Daily Brief journalist Tom Geggus. Today I'm speaking with Lucien Mathieu, manager overseeing road vehicles and e-mobility analysis at Transport and Environment. We'll be discussing the carbon footprint of electric vehicles. So without further ado, let's get straight into the discussion. Lucien, thanks so much for joining me today. I really appreciate you taking the time.
Thanks for the invitation, Tom.
Well, I think we should start things off by talking about a tool you actually built last year for Transport and Environment. It measures how clean electric cars are. So can you tell me a little bit about it?
Yes, absolutely. So we decided to do this tool because we felt that there were still too many, biased analysis which were done on the life cycle emissions of electric car. And we felt that there's still a need to debunk these studies, even though the overwhelming majority of the research and the evidence points out that the electric cars are today much cleaner than their conventional equivalents. So, for example, compared to a petrol car. So we decided to bring the most up-to-date evidence because, unfortunately, in those biased or misleading analysis that we can see, there is often they rely on data which can be quite outdated. So, for example, which is 2, 3, or 4 years old, and which therefore does not really reflect the current state of the technology. Because battery technologies, for example, are evolving so fast, the impact of a battery 3 years ago can be 2 to 3 times higher than today. And so that's why you really need to be up to date on this question and look at the latest evidence. Something else that we try to do with this tool is to be forward-looking, which means that we not only offer the possibility to compare in the year 2020 the different emissions from the different powertrains, but also offer the possibility to compare the emissions in the year 2030. Because the majority of the electric cars have actually not been sold yet. So it's also important to understand how the different powertrains will and their performance in terms of climate and CO2 emission will change in the next years. And finally, also the reason why we decided to make a tool is because this is quite a complex topic when it comes to life cycle emissions of electric cars and comparing them. There's many parameters to take into account. What is the electricity that is used to charge the car? Where does the battery come from? How was the battery produced? So all these questions can make a significant difference on how much cleaner the electric car is. So to take that into account, we have made an interactive tool where the user actually is able to select these different options. For example, selecting electricity from the average Swedish grid, or selecting a battery made in China or made at Northvolt in Sweden. And this allows the user the opportunity to understand the complexity of the problem and also compare the different options by himself, and therefore understand much better the issue of the life cycle emissions of electric cars.
You spoke a bit about potential industry biases. So where did T&E's data come from?
Well, we use the multiple sources for the data. Maybe just to list a few. For example, when it comes to the emissions for the production of the battery, here we used a meta-analysis done by a Swedish institute actually called IVL, which they did back in 2017 and they updated it in 2019, a meta-analysis for the emissions from battery production. When it comes to the emissions due to the electricity production, here we used a source called ENSOE, so that's the European Association of Electricity Transport Network Distributors. So what are other sources? For example, we used also IPCC for the emission factors from the electricity generation of each of the kind of power generation. So, for example, life cycle emissions from renewables, but also life cycle emissions from coal generation, from gas generation. And maybe to name a final one is also we used a website called Sprit Monitor, which is a website which registers the real world consumption of vehicles. So it's basically used and maintained by drivers like you and me, who input on the website the consumption of their vehicle that they observe in real world. So it's quite a large database, which is very representative of what we would see on the road, more representative than tests which are done in the laboratory and not very much and too optimistic compared to what we see on the road.
So Lucien, it sounds like there were an awful lot of data points that you considered here for the tool. Could you tell me a bit about the different life cycle stages that you considered for an EV?
Well, yes, absolutely. What we did is a life cycle analysis here. So the principle of that is that we take into account all of the different stages along the life cycle of that product. So here, the electric car or the petrol car. The first phase is, of course, the production. So in that production, it includes the extraction and refining of raw materials. For example, when you think of an electric car, you, of course, think about the battery and the lithium, nickel, cobalt, which is in there. Well, we do include all the extraction, refining, transportation, battery production. So that's for the production, the first phase. Then comes the use phase, which is the majority of the impact of the vehicle. For the petrol car, this is mainly the tailpipe emission, so what basically comes out of the tailpipe. But we also have some upstream emissions for both the electric car and the petrol car. So the upstream emissions for the electric car are the emissions generated from the production of the electricity, which the electric car is running on. And when it comes to the petrol car, here we have upstream emissions from the production of that fuel. So when we extract crude oil, when we refine it, when we transport it, so all of this also has an impact in terms of emission. So that's for the upstream emissions of the use phase. And then finally, there's the end of life. So in there's the recycling, of course. For that last point on recycling, it's still very challenging to take that into account when it comes to the battery, because there is not a lot of evidence when it comes to recycling of battery yet, simply for the reason that electric car batteries are still on the road. They have not reached the end. For the huge majority of them, have not reached the end of their life. But that will be quickly changing over the years as we have the ramp up of recycling production in Europe and in the world. So hopefully we'll have more evidence on that last point, which will, of course, also lower even further the impact of the electric car, as by recycling cobalt, nickel, or lithium, it also means that you need to use less of those primary materials. So to extract less lithium, and produce less of those batteries from virgin raw material. And this, of course, has a positive impact on the production of the battery.
So it's really about taking the entire lifespan of the vehicle, not just when it's on the road, not just through production, but as you say as well, with recycling being such an important part of what an EV could be, really quite fundamental. So I think it's worth identifying now some of the results and findings that you found through this tool. Last year, you did discover that an electric car is already close to 3 times better than an equivalent conditional car, because obviously this tool is about comparison. It's about taking an EV and saying, okay, this is what it can do. Let's see what it is like compared to a conventional petrol or diesel car. Do we still think that 3 times better number is the same?
Well, roughly, yes. It's still the same, Tom. It doesn't change that much from one year to another. But the beauty of electric cars is that they get better and better every year. And that's for several reasons. First of all, maybe the most obvious one is that our electricity grid gets cleaner and cleaner. As we put up more and more renewables, we phase out coal generation plants. So this allows us to have more and more decarbonized electricity grid. Sweden already has a very clean grid. That's great. But this trend, we're also seeing it happen all across Europe. So, for example, the electricity that an electric car would use today is on average cleaner than one that would be used last year, for example. So that's one thing which makes electric car better over the years. But there's another point which is closely linked to the battery. Here, it's first of all, the improvement in the battery chemistry and the battery densities, which make them also cleaner. Just to take an example, with new chemistries, we have improvement on density. What does this mean? It means that for a same battery, you need less material to do it. Less material also means, of course, lower impact, environmental and climate impact. And the last point, which also plays in favor of electric cars over time, is also the economies of scale in the production of the battery. we're seeing more and more of these so-called gigafactories all across Europe, where we produce batteries on very big scale. As researchers from the IVL in Sweden have also shown, has led the carbon emission from the production of the battery to drastically reduce over the past years, given that maybe 3 or 4 years ago, these factories were very small scale, so not very efficient. They were almost kind of pilot stage. Now it is a more and more mature industry, which is getting more basically cleaner, and makes cleaner batteries as well. So we have not yet looked at the figures, but what we've shown last year, which basically showed that electric cars are almost 3 times cleaner than the average petrol car. Well, today probably the figures would be even better for electric cars, but still in the same range of probably around 3 times cleaner over the lifetime.
So when we say that an EV is 3 times better than a petrol or diesel car, the equivalent conventional car, across its life cycle, what average number do we have there that we're comparing?
So the numbers we're comparing are in terms of tons of CO2 emitted over the lifetime of the vehicle. So I will use, let's say, rough figures to illustrate. But for an average electric car, over the lifetime, we are looking at around 20 tons of CO2 emitted. Half of that would be for the production of the vehicle, including the battery. And the other half would be for the use phase, meaning the production of the electricity used to power that electric car. On the other hand, if we look at the average petrol car, we are close to 60 tons over the lifetime of that vehicle. So you see 60, that's roughly 3 times more than the 20 tons for the electric car. Out of the 60 tons for the petrol car, let's say around 6 or 7 tons are for the production of the vehicle. So here that's less than the electric car because there's no battery. And the rest is for the use phase, meaning the combustion, so the tailpipe emission, and also the upstream emissions, which I mentioned earlier for the extraction and refining of the petrol fuel.
Sure, let's try and get a bit more specific using this tool that's on your site. So let's say in the EU 27 countries, comparing 2 medium-sized cars, both bought in 2020, one with electric drive, let's say, for example, you might have a VW ID3, and one with a petrol engine, so a VW Golf. Your tool points to quite a stark difference. The EV would produce some 90 grams of CO2 per kilometre versus the petrol at 253 grams. Then considering the number of tonnes of CO2, as you said, produced over distance driven, we see the petrol skyrockets to about 60 tonnes past the 200,000 kilometre mark, while the electric barely gets around 20. So why is there such a large difference between EVs and petrol, and particularly over time of use?
The main reason behind that is the very high emissions during the use phase of the petrol car. Even though the electric car start off, let's say when the electric car gets out of the gate from the production factory, it has what is sometimes called a carbon debt, because the production of the vehicle emitted more CO2 because it has a battery compared to a petrol car. But that carbon debt is very, very quickly paid off. On average, it can be depending on how much you drive, but it can be in 1, 2, maybe maximum 3 years. Also depends on the electricity that is used to charge the vehicle. So that carbon debt is quickly paid off, which means that when it hits that breaking point, the petrol car will be emitting much more compared to the electric car. And now I'm coming back to the main reason, and that's because the petrol vehicle has high emission during the use phase. And the key reason to that is that it is very inefficient. A petrol engine is only transforms about a third of the energy in the fuel into actual movement. The rest is lost in heat. Whereas for an electric car, there is no fuel that is burned in the motor. There is no heat that is dissipated. So close to 95% of the energy of the electricity from the battery is actually used to propel that car. And this difference in efficiency is the key underlying reason to understand why the emissions in real world on the road for the petrol cars are actually very high. And to take that into consideration, you have to look at the real world emission and not the lab emission, which are very ambitious based on laboratory tests, and which are not in line with what we see on the roads.
So obviously there's a lot of things happening in the world of electric vehicles, and there's still an awful lot of change going on, especially as you mentioned earlier with the recycling of batteries. Is this tool going to be kept up to date? Can people still check out this tool in, say, 3 years maybe, and it'll still be as applicable and up to date as it is today?
Absolutely, and that's our ambition. And actually, we will update this tool in the first half of the year of this year. We will try to do that annually. So every year, in the first half of the year, we want to update the tool with the latest evidence, the latest findings when it comes to the different stages of the life cycle emissions of the electric car. For example, we know that, and every year we are almost surprised by the speed, at least in Europe, by the speed at which renewables are replacing coal and fossil fuel electricity generation. And actually, last year was the first time that renewables surpassed coal production in the EU. So with renewables hitting 38% of the electricity production in the EU. So this is something we want to take into account in our updates for this year. But we will also widen the scope of our tool and extend it to other drivetrains. So what we'll do in the next month is adding plug-in hybrids, because we feel that we have more evidence today. We didn't have enough evidence last year regarding how PHEVs, so plug-in hybrids, are actually driven, if they're charged a lot or not. Now we feel that we have the necessary evidence, so we will update that, and the tool will allow to compare a plug-in hybrid with a petrol car or with a battery electric, and maybe even at a later stage we could add hydrogen fuel cell cars as well.
So it sounds like the tool is going to be really, really useful, not only this year but next year and the year after that and continuing. So that's fantastic news. And of course, we'll provide a link to this tool down the show notes below. So thank you very much for that. And Lucien, I'd like to thank you very much for your time as well today.
Thank you very much for your time as well, Tom, and thank you for the invitation. I really enjoyed speaking about this topic today. Thanks.
Thank you very much for watching this video. If you've enjoyed it, please don't forget to give us a like and subscribe. Also, have a look for us on Twitter, Facebook, and LinkedIn. And don't forget to subscribe to the Daily Brief email. If you've enjoyed this video, then it forms part of a larger multimedia article. We'll leave a link down in the show notes below. Thank you once again for watching. We'll see you next time.